Now how to derive second order integrated rate equation. First you have to write the reaction A plus B, it gives product. Means the reaction is started with different reactants and with different initial concentrations. Means A is not equal to B. Initial concentration of reactant A is small a and that of reactant B is small b. The initial concentration of product is 0, that is at T is equal to 0. At time T is equal to T, the product concentration is small x, and obviously the concentration of reactant A left behind is A minus x and concentration of B left behind is B minus x. We know that rate is equal to minus dA upon dt is equal to minus dB upon dt, or is equal to dP upon dt is equal to K2 into concentration of A into concentration of B. It is also equal to dx upon dt. Okay, so dx upon rate is equal to dx upon dt is equal to K2 into concentration of A, which is A minus x, into concentration of B at time t, which is B minus x. Now the equation is dx upon dt is equal to K2 A minus x into B minus x. Okay, you have to rearrange the equation, bring the concentration terms on one side and move dt here. Okay, so before integration we have to write 1 upon A minus x B minus x dx is equal to K2 dt. Here subscript 2 stands for the rate constant of second order reaction. Okay, now you can resolve this into this. Just for your information, I can show you 1 upon A minus x B minus x is equal to 1 upon A minus x B minus x. You have to multiply numerator and denominator by same term A minus x minus B minus x. Now you have to open up the bracket of denominator. You will get this A minus x minus B plus x. So here plus x minus x get cancelled. You will get this term. Okay, move this concentration terms here. You will get this 1 upon A minus B into this one. So it is equal to 1 upon A minus B. You can split this A minus x upon A minus x B minus x minus this one. So A minus x get cancelled. B minus x get cancelled, and you will get this 1 upon A minus x B minus x is equal to 1 upon A minus B into 1 upon B minus x minus 1 upon A minus x. Okay, now you have to integrate this. So after integration, this is the out of integration, and you have to integrate here and here. Okay, so integration of dx upon A minus x B minus x is equal to 1 upon A minus B. Simultaneously you can write down into in bracket integration of dx upon B minus x minus integration of dx upon A minus x, bracket complete, is equal to K2 integration of dt. So 1 upon A minus B is out of integration because it is constant. So after integration we get minus ln B minus x minus ln A minus x. So minus ln B minus x means it should go in denominator side. Okay, here, and minus plus ln A minus x, it should go in numerator side, is equal to K2T plus C, constant of integration, which is 1 upon A minus B ln A minus B, sorry, A upon B. So when you put the x is equal to 0, you will get this term. Substitute this C in the above equation, equation number 17, you will get this equation. Now you have to rearrange the equation, bring the concentration terms on left hand side. Remember that 1 upon A minus B is common. Okay, so it is out of the square bracket. Move this T here. So 1 upon a minus b into t in square bracket ln a minus x upon b minus x minus ln a upon b. Here plus sign, after changing the side you will get the minus ln a upon b. Now here minus ln a upon b means b should go here and a should go in denominator side. You will get this equation. This is the integrated rate equation for second order reaction with unequal initial concentration, and we assume that the concentration of A is greater than concentration of B, okay, reactant B. So A is greater than B. You will get the integrated rate equation for second order reaction. This is the integrated rate equation for second order reaction. K2 is equal to 1 upon a minus bt ln b into a minus x upon a into b minus x. So again I will recall the steps. First write down the equation, concentrations, then rate is equal to dx upon dt k2 a minus x b minus x, okay. Then integrate it. After integration you will get equation number 17. Put the value of c in equation number 17. Rearrange the equation. You will get this. After rearranging you will get the final equations, okay. You can watch the video again and write it down.